Let's consider an example dealing with gravitational forces. So we have two everyday objects. We have two semi-trucks parked next to each other. One is fully loaded, and we have the mass, and the other one is empty, and we also have the mass. The distances between the centers of each truck, from the center of one truck to the other center of the other truck, is 3.05 meters. So if we just draw a diagram and see what we have, here is one truck. And then here's the other truck. We know the mass of each truck. We've got a 36,364 kilograms, and then the other truck is 15,909 kilograms, and center to center on these trucks 3.05 meters. So in part A, we want to calculate the gravitational force. So Newton's law of gravitation, gm1 m2 over r squared. So we'll write out the equation that we're using, and then fill in the values. Remember, capital G, gravitational constant, 6.67 times 10 to the negative 11th, Newton meter squared per kilogram squared. And then your two masses in kilograms, 36,364 kilograms, and then multiplied by 15,909 kilograms. R stands for the distance between the centers, which is the value that we have, 3.05 meters, and remember to square that. When we plug that in and we calculate, we get the gravitational force of attraction, 0.004 newtons, and then the vector direction is that they attract toward each other. Not a very big force, but then your objects, even though they're decently massive, they're not as massive as planets or stars or things, so still not that large of a force. Now in part B, we want to calculate the gravitational field strength at a location 3.05 meters away from the fully loaded truck. Well, the fully loaded truck has to be the more massive one, and so we want to know what the gravitational field strength is 3.05 meters away. So then right here, we want to know what is our value for gravity. Well, there are a couple of different ways we can think of this. That value for gravity, that's a ratio of the force on the object divided by the mass of the same object. So then the force on the blue truck, which we have a value, divided by the mass of the blue truck. We also drive that down into the equation, G times the mass of the body over r squared. Now if you're using this is the object that is causing the gravitation to exist. So this would be capital G times the mass of the filled truck divided by your distance squared. Either way will give you the same thing. I'm going to use this way because we have those values and it's a little bit shorter. So 0.004 newtons divided by the mass, and that's the mass of the truck at that location, 15,909 kilograms. So we calculate that, we get a value of 2.51 times 10 to the negative 7th. You can write this either as newtons per kilogram, or it is an acceleration due to gravity. You could write these units as meters per second squared. Those units are equivalent to each other. So then, kind of in summary on our gravitational field equation, if you know the force, that's going to be the shortest way. If you only want to calculate the value of gravity at some location, but you don't have an object there, the second equation is going to be probably the one that you need to use. Ponder physics.